So today we're going to look at kind of a special resistor circuit called a voltage divider. These are useful if you want a specific voltage that you don't get from your power supply or from your battery. They're not as precise in voltage as, say, a voltage regulator, but in a pinch, it can get you a voltage. So what we have here is we have power coming in from our 9-volt supply across two resistors. This is a 1K and a 2.2K. And if we check across the whole thing, our voltage drop is 9 volts from what's from the power supply. Now if we check here, we have 2.8 volts, which means we should have about 6 volts of drop across here, a little over 6 volts of drop across here. And what that means is if we hook something up to minus here and then put its positive here, it'll get roughly 6 volts. So we've taken 9 volts and divided it down into 6 volts. And Ohm's law can show us how that works, and here's a formula for working out how many volts come out of this. Okay, so we have our little voltage divider that we just looked at, and we can actually, using Ohm's law, work out what our voltage will be. It's just a series circuit, so V equals IR. The total voltage drop across everything is 9 volts, and our resistance is 3,200 ohms. So if we go 9 volts, divide that by 3,200 ohms, that'll give us 0.0028125 amps. Okay, so about 0.28 amps. So if we then work out the voltage drop across our 1K resistor here, so current is 0.0028 amps times 1,000 ohms gives us about 2.8 volts. And then across our 2.2K resistor times 2,200 ohms gives us, in this case, about 6.16, so 6.2 volts, which is roughly what we got when we were looking at it in the lab. Okay, now this can tell us what our voltage drop is. So we will get out of this circuit a 6.2 volt, 6.2 volts coming out of there. Now this can be a bit of a work, and there is another way of working out the voltage divider, and that is the output voltage. In other words, here, so if this is V out, this will be V in. It's going to be equal to our R2 resistor. Now this is R3 because of the way KiCad works, so if we call this R2, divided by R1 plus R2 times input voltage. This formula here will tell us the output voltage without having to do all this Ohm's law stuff. So we can just put our numbers in. So R2 is 2,200 ohms. That's going to be divided by 1,000 ohms plus 2,200 ohms times 9 volts, which provides us 2,200 ohms over 3,200 ohms times 9 volts, which gives us, again, 6.2 volts. And we get the same number that we did here. So this is just an easier formula to use for a voltage divider than having to do all the Ohm's law pieces. Called a potentiometer. Now, if you want a variable resistance, you basically generally just use 2 of the inputs. There's 3 inputs. If you just use the 2 outputs, it's in this case a 100K potentiometer, so you'd get a 100K resistor. But this middle one's hooked up to a wiper inside, and if I turn this, it changes the resistance inside there. And because that now creates basically 2 resistors, this makes this a voltage divider, and that's why it's called a potentiometer, because we're changing the electric potential with it. And by changing this, we can change the voltage. So we can get that hooked up to take a look. Now I'm just going to hook it up like this. use some alligator clips to hold everything together here, because it'll make it a little easier for us. And we'll put the positive one here. And we can check that, you can see that the voltage drop across the whole system is 9 volts, because that's our supply. And we'll connect that there. Now we see that's 4.6 volts. As I turn this, it can drop down, or it can increase, which allows me to change the voltage variably. So that's why these potentiometers are often used for things like volume and all that, because we can change the voltage by simply changing the position of the potentiometer, giving us a different voltage. Another useful thing you can do with a voltage divider is that if we have a sensor that's resistive, in other words, its resistance varies, we can put it into a voltage divider and then detect the change in voltage using, say, an analog to digital converter on a microcontroller or whatever, and that'll tell us, that whatever we're sensing has changed. So here we have a little circuit. It's a 4.7K fixed resistor here, and it's connected to a light-dependent resistor. Now the resistance of this LDR will change as the amount of light falls on it. And I've got the voltmeter hooked up to measure the voltage drop across our bottom resistor here, our fixed resistor. And as I cover it up, you can see that the voltage changes. Because for an LDR, if I take light away, its resistance goes up. If I give it light, its resistance goes down. And so if we were to hook this up to, say, something like an Arduino or something that has an analog to digital converter, we can measure the voltage change and then use that to have the microcontroller make a decision. And this could be used for any resistive sensor. So if I had a thermistor, I could put it there and do the same thing, except that with the temperature changing, the voltage would change.